Our lesson for today will be looking at Chemistry 1502. Today's topic will be looking at different types of structures, which are the structures we can represent compounds. This is lesson 101. Let us start. Throughout the course of this lesson series, different types of topics, we've been dealing with Lewis dot diagram. So today we'll be looking at a different way to represent different types of compounds using different types of structures. Let us start with our first example. C2H6 means that we have this compound that has 2 carbons and 6 hydrogen atoms. So basically, if we were to represent this using a Lewis dot diagram or Lewis structure, we would basically draw it like this. Then we are going to have our terminal atoms as hydrogen. So this would be the Lewis diagram of this compound. For now, I'm not going to say the name of the compound. In the next lesson series, we'll be looking at different types of these types of compounds and their names, also their properties, and how we can best draw their structures. I want you to be familiar with other structures here. Since we know what is the structure, we call this a Lewis diagram. And then, by the way, we call it a molecular formula. Now, looking at a condensed molecular formula, let us look at the first carbon. Suppose this is the first, this is the second carbon. Let us look at the first carbon. How many hydrogen are bonded to this first? We have 3 hydrogens. So we can just write the summary of this. We have CH3, and then looking at the second one, which will also be CH, it also has 3 hydrogens. And then we can represent this using just a structure, but that structure will only show the bond between carbon and carbon. So we can write it like this. Sometimes it will be written like this. But you should understand that it is best that we put this hydrogen here so that it shows that the carbon, the bond is between the two. Now, another structure that you should be familiar with, it's the skeletal structure. Skeletal structure, in this case, it will simply be a single line. The properties of this single line, you should know that each and every ends of this line, it represents carbon. And then you know that carbon is a tetravalent atom, meaning that it bonds 4 times. Automatically we should be having our 3 hydrogen. So skeletal structure in this case represents the ends. The ends will represent our carbon, then each carbon will have these terminal atoms. Let us look at another example so that you can be familiar with especially this and this. C3H8. So we can represent this using a Lewis dot diagram. So you can count the number of hydrogens. We have 8 hydrogens. And then looking at the condensed, we have CH3, CH2, CH3. Looking at the skeletal structure, we're going to have something like this. Remember, here we have our carbons. If this is carbon number 1, 2, 3, then we'd have 1, 2, 3. C3H6. So we have our 3 carbons, but we can see that if we put 2 hydrogens here and 3 hydrogens here, we are not going to get a total number of hydrogen as 6. We're going to have more than that. It will actually be 8. So it simply means that we have a double bond somewhere. So we can just put our double bond here. And remember, the double bond cannot be between hydrogen and carbon. Since hydrogen, it can only bond one time. So we can go ahead and fill in the remaining bonds. Just have to make sure that we have the most stable structure where the formal charges will be 0. So you can see this carbon, it bonded 1, 2, 3, 4, so it is okay. And looking at the other ones, they've also bonded 4 times. Looking at the condensed structure, the first carbon has only 2 hydrogen, the second one only has 1, and then the third one has 3 carbons. And then looking at the skeletal structure of this, we are going to have something like this. Then we have to represent this pi bond, then we can simply put it here. Then looking at the carbons, this will be the first, second, and third. We can represent this compound in many ways, but let me represent it like this. I'm going to put this double bond here, then you're going to have something like this. If you can check all the carbons, they are satisfied, and also oxygen, then we can just put our lone pairs here. In this case, if we were to write a condensed structure, it will be CH3CO CH3. This simply means that our oxygen is on the second carbon. Then looking at the skeletal structure, we're going to have something like this. Our last one, C5H12. So we're going to have 5 carbons. Then they'll have sigma bonds, because looking at the sum of these hydrogens, they should give us 12. So we have 3, we have 5, we have 7, we have 9, we have 12. So you can see that it is okay. And then looking at the condensed structure, it will be very simple. We have CH3, CH2, CH2, another CH2, CH3. Then looking at the sum of this, they should give you the number of the total number of hydrogens we have. Then looking at the skeletal structure, this will be 2. You can see the way I count. You don't start by saying 1, but you can start by saying 1, 2. It's 1, 2, 3, 4, 5. Then let's say if we had a double bond here, then it would simply mean that this is carbon number 1, this will be carbon number 2. We'll simply put it here. Then if we had another bond, let's say here, then we'd have to locate it's 1, 2, 3 between 3 and 4. So it's 1, 2, 3, it's between 3 and 4, then we can put it here. The skeletal structure is very simple. if you understand its basics. So it is very important that you go through this lesson video, because on the next lesson videos we'll be dealing with these type of concepts more before we can even get to the functional groups, the homologous series, the isomers. We need to understand this. That's it for this lesson video. This is Bahula SJ. Thank you very much.